All right. Today we're going to talk catastrophic volcanic eruptions. So your ultraplenian eruptions and resulting landforms, which are called calderas. We'll discuss how calderas can come in different varieties and show up in different places. We can look at, we're going to look at several examples of how this happened, not the least of which is Yellowstone National Park, which is probably the largest caldera in the US and maybe one of the largest in the world. And we'll kind of distinguish then, also talked about some volcano monitoring and warning, distinguish between active, dormant, and extinct, and give some examples of how that all works. So here we go with ultraplenian eruptions and calderas. So we've talked about Plinian eruptions already, and these are explosive eruptions with billowing clouds of hot ash, gas, and air blasted into the upper atmosphere. And in a ultraplinian eruption, this happens, but at a grand scale. Typically, the big difference is the magma. The amount of magma in an ultraplinian style eruption is significantly more. And so when you actually have the eruption occur, so much material is erupted out of the magma pocket that it leaves behind a void, and that void is filled up, of course, from the ground collapsing down. And so you have left behind a deep gouge in the earth we call a caldera. You can see a picture here of the ultraplinian eruption occurring. Again, this would be ultraplinian because it's catastrophic and large, and also because the magma pocket is so large. After the eruption takes place, the whole area drops down. Note that this particular picture is of a stratovolcano, an eruption from ultraplinian style and a resulting caldera left behind. So calderas on stratovolcanoes do occur. Some examples here: Krakatoa volcano in the Krakatau island of Java in Indonesia, left one behind. We have Mount Mazama, which is Crater Lake in Oregon. We also have the Thera volcano in the Greek islands in Sicily. And you can see the Santorini island there in the Aegean Sea. So lots of big eruptions that have occurred even off of the top of stratovolcanoes. In the case of Krakatoa, it erupted in 1883, August of that year, and it was an Indonesian volcanic island arc. Indonesia itself is a volcanic island arc, and it's got lots of volcanoes that are pretty active. But this one erupted 1883. It was such a powerful eruption, it said that it could be heard thousands of miles away. And this one blew off about 200 plus feet above the island and another 200 some feet below the island and caused a major tsunami that raced across the ocean. You can see pictured here the Indo-Australian plate subducting under the Eurasian plate here, Mount Toba, which we'll talk about later. Here's Krakatau, Merapi, Tambora, all very active volcanoes along this front. Before it erupted in 1883, it was quiet for 2 centuries. And it started off with volcanic eruptions that kind of cleared the throat of the volcano. And then the volcanic eruption, or the ultraplinian eruption, began on the 26th of August of that year. They said that it was said that the pyroclastic cloud went about 50 miles high. That tephra covered 300,000 square miles around the area, and the eruption was heard 5,000 kilometers away. Again, that tsunami was thought to kill about 36,000 people. So you can see the island before here, and then the island, of course, gone after. Another ultraplinian eruption out of a stratovolcano occurred atop Mount Mazama, which is in Oregon, about 7,600 years ago. Mount Mazama was one of the Cascade Range volcanoes, but there was, again, a huge magma pocket underneath this volcano. And when it erupted, it dropped down and left behind a huge cavity in the earth, which filled up with water and is now called Crater Lake. Has anybody ever been to Crater Lake here? It's in Oregon. It's beautiful. And there's kind of an island in between. It's a little lava dome left behind from a later eruption about 1,000 years after. That's another example of a stratovolcano atop, or excuse me, a caldera atop a stratovolcano. There's also these things called resurgent calderas. And these are basically like giant continental calderas. These are areas where large volumes of basaltic magma intrude into shallow depths. They melt the surrounding continental crust, get very thick and sticky, and therefore explosive. And so the magma pocket, again, so large that it begins to erupt out the same area it may have erupted in before. And of course, Yellowstone is our main example. You can see the picture here with basaltic magma intruding underneath, melting the crust here. Lots of earthquakes occur because of the magma adjusting under the crust. And then, of course, it heats the groundwater to produce geysers and hot springs and all the rest. Yellowstone erupted about 600,000 years ago. It's due to erupt again. You can see here the Yellowstone plateau and depression from the caldera right here. You can see Mount St. Helens in 1984 scale, the ash cloud that resulted from eruptions of Yellowstone can be seen all the way to the Mississippi River, covering much of the western half of the U.S. And you can see it's a series of eruptions that occurred at hotspot, and this is millions of years ago here, marking the fact that the last one occurred 0.6 million years ago, which is 600,000 years ago. So here's Yellowstone National Park. Just south of that is Grand Tetons National Park. Another resurgent caldera can be found north of Krakatoa, which we talked about earlier. Here's Mount Toba. Mount Toba is thought to be one of the largest eruptions in history. 74,000 years ago, it's thought to have occurred, and there's a huge caldera left behind from this ultraplenian style eruption, probably the largest known. Incidentally, there's a bottleneck in the human population at the time. Archaeologists note that for some reason, the population of human beings drops super low during this time, about 75,000 years ago. Perhaps Mount Toba was responsible. There is, of course, a huge caldera, and it's filled up with water now, so there's a lake left behind. And you can see it's on the island of Sumatra here, located in the northern part. Again, the whole tectonic setting is that Indo-Australian plate subducting underneath the Eurasian plate there. Here's a look at the resulting crater lake, which is enormous, and beautiful scenery from this particular caldera. Here's a look at Toba and Yellowstone from 600,000 years ago, noting how extremely enormous that they are. And there's Crater Lake. Again, caldera-style eruption. So, I wanted to talk also a little bit today about this idea of active, dormant, and extinct volcanoes, just to get a sense of what's going on in the world and what we could expect moving forward. I took this picture here from the 14th of December of 2020, and this one showing the active volcanoes currently erupting on the Earth's surface. At any given time, there's usually about 50 volcanoes erupting. About 600 volcanoes are considered active, and those are ones that are erupting within historic times or more currently. We use the term extinct volcano to represent a volcano that hasn't had historic activity, it's deeply eroded, and there's no magma going on. An example might be this one, the cinder cone at Sunset Crater Volcano National Monument in Arizona. Beautiful remnant of a past eruption, now thought to be extinct. Yellowstone would not be called extinct. We would call Yellowstone dormant. And it's sleeping, a sleeping volcano. This is because Yellowstone is deeply eroded and hasn't shown historic eruption activity, but definitely magma exists underneath. It's showing very much uh, hot springs, geysers, uh, seismic activity, showing that this volcano is got some serious magma operating on below. Another dormant one that we can expect to erupt in the future, maybe near future, maybe not. Mount Rainier in Washington. This is part of the Cascade Range volcanoes. It's north of Mount St. Helens. Um, it's somewhere between active and extinct. It has had historic eruptions. So a dormant volcano, as we said, could be dormant for millions of years and then become active, all of a sudden making them very dangerous. Mount St. Helens was considered dormant before it erupted 1980. It was dormant for about 123 years. This is the eruption picture, beautiful picture of the eruption from May 18th, 1980 here. And Mount Pinatubo had been dormant for 400 years before it erupted in 1991. And this was a cataclysmic eruption. This was like a VEI of 6, really strong eruption. You can see picture here, pretty amazing. And then Mount Vesuvius, it was considered extinct before it erupted in 79 AD and completely wiped out 2 whole populations on both sides of the volcano. And here's Naples, Italy today. Again, we talked about this one earlier. Just crazy the amount of people that are living next to this clearly dangerous volcano. When volcanoes show activity, they monitor them. So I wanted to discuss that briefly before we part ways here today. Volcanoes are monitored for their precursor activity. And I have a list of some of these activities below. These are environmental changes that accompany the rise of magma towards the surface. Seismic activity happens. Ground starts to bulge. So we actually can put in tilt meters in the ground and they measure the amount of ground deformation. Hydrothermal phenomena, including increase in temperature in hot springs, steam release, geyser activity, that kind of thing. Rise in temperature of crater lakes. And then, of course, chemical changes, of course, also occur. Things like increase in sulfur dioxide or even release of CO2 into the surrounding ground, killing little animals and vegetation around the base of the volcano. When Mount St. Helens erupted, there were 4 large earthquakes near Mammoth Mountain in Long Valley, California, which was uh, right here in Central California. It's not part of the Cascade Range, but it is part of a series of volcanic eruptions that occurred as part of an Ultraplenian suite 700,000 years ago. So it's a resurgent caldera there, which is, of course, a big problem, especially in Central California. So after the Mount St. Helens erupted, they got a little squeamish with these earthquakes happening, and they put the areas on alert as a potential volcanic hazard. Of course, the volcano hasn't erupted, so the folks at the time were pretty upset because housing prices dropped, tourism declined, that kind of thing. There was no eruption. So that's something that people, I mean, the USGS did their best, but there's other considerations with that, right? Trees began dying in the 1990s because of CO2 released from under the ground. Small earthquakes have resumed. The ground surface is bulging. Volcanologists are hesitant to release that alert after the false alarm of 1982, so they just want to prepare for the worst but hope for the best here. But this is Long Valley, so that's an example of a volcano that you would want to monitor. And here's what it might look like underneath with a huge pocket of magma underneath, and there's crystallized magma below that, but the magma upsurging is causing this whole basement rock to shift and move, causing major earthquake activity, bulging, and everything like that. Lastly, volcano warning. So when they're monitoring a volcano that's showing signs of erupting, they of course want to warn people and get them out of harm's way. Mount Pinatubo, when it erupted in 1991, I showed you that picture earlier there. It was the largest eruption in the 20th century. And there were about 1 million people in the danger zone of this volcano. After about 500 years of being quiet, there were thousands of small earthquakes. There were 3 small steam blasts that emitted SO2 gas. And so they began monitoring this very intensely. On June 7th, the lava dome formed in kind of like a mini eruption. On June 12th, large explosive eruptions began, and so they evacuated the area, including clearing out a military base nearby. And then on June 15th was that cataclysmic eruption, where you had magma and rocks spraying up into the atmosphere tens of kilometers. Pyroclastic flows, which is that big billowing cloud, 200 meters deep, billowing out from the volcano. And then actually a typhoon blew in as well in the days after, causing volcanic debris to wash down slopes and create lahars, which are those volcanic mudflows you see pictured here on the right. The final assessment, though, only 300 people were killed because of the warning that was issued and the evacuation that ensued. There would have been many more deaths without that. They saved a lot of military property as well as a result of moving out of harm's way. You can see a picture from the military base there in the Philippines as looking on Mount Pinatubo as it erupted. That's pretty impressive. So that's a look at ultraplenian eruptions and the resulting calderas, as well as how we monitor volcanoes and try to issue warnings for folks to keep them out of harm's way.